Okay. I'm just gonna start talking all over 2A all over again, and then we'll do 2B. So what was going on in these problems, again, I'll just kind of erase most of it. So in 2A, I said write the sine and cosine equations for these pictures. So essentially we're going backwards from what we've been used to doing. Normally we go forwards and I give you an equation and you graph that. This time we're going backwards. I'm going to give you a graph and we're going to draw an equation from it. So I always start by setting up, and I have a sine equation and I have a cosine equation. We have not moved up and down yet. We'll worry about that today, but we have not moved up and down yet. So first thing I care about is altitude. Then the next thing we're going to start caring about is our period, our B. I think I have that in blue. Yep. And then the last thing we're going to do is worry about moving it left and right. So these are kind of like the spots that I have to fill that we're going to fill based on the graph. Okay. And again, you probably already have this done. I'm just talking through it again, especially if we were rushing at the end or if you didn't have it fully filled out. Okay. First thing I think when I look at this is what graph do I physically see? I actually see a sine graph. So I see as much of a sine graph as possible. You guys all see that? So I'm going to start by thinking about sine. Okay, I think the easiest first thing to do is our amplitude. Our amplitude is how high it goes from the middle and how low it goes from the middle. So it looks like the middle of the graph is my x-axis. So I go as high as 1/5 and I go as low as -1/5. So that means my amplitude is 1/5. Now, we are going to use that for my cosine graph as well. The only difference in my sine and cosine graph is going to be my left and right movement. The period, the B that's going to be the same, the A, the amplitude is going to be the same. The only thing is the horizontal shift, my C left and right. That's my only difference here. Okay, so I can use my amplitude for sine and for cosine. Okay, that being said, let's do my period shift, my horizontal, my left right movement first for sine, and that's going to help me find the B for my period. So normally we start sine at 0, 0, right? This time I didn't start there. I started at what? Pi/6. Good. So did I move left or right to get to pi/6? Right. So that means I'm going to say minus pi/6 to show that I went to the right, pi/6. So my shift there, my C is minus pi/6. We'll do our C for cosine in a second. Let me get to the period next, okay? Okay, so normally when we look at our period for sine, I'm just going to scroll back up to like our original graph. Our period for sine is normally 2 pi. Okay, that's from where we start to where we end. And normally we start at 0 and we go to 2 pi. Okay, however, we're not starting at 0. We're starting at pi/6. So to think about where I'm ending, I'm going to take the last point and minus my shift. I'm going to minus this pi/6 to get us back onto 0. That's like taking my graph and instead of starting it here, moving it so that I actually start here at 0. Are you guys okay with that? So that's why, and I believe we did this in class the other day, but that's why I'm about to do 5 pi/6 minus pi/6, because that's going to mimic what the actual horizontal length of my graph is. So 5 pi/6 minus pi/6 is 4 pi/6, which is the same thing as 2 pi/3. So my period is 2 pi/3. Okay, that's not helpful yet because that doesn't go in my equation. What goes in my equation is my B. Again, I'm going to zoom back up just to remind you. When I taught you all of these transformations, I told you that we find the period by doing 2 pi divided by B. So 2 pi divided by a number should equal what the period is. Well, my period is 2 pi/3. So 2 pi over what number would give me 2 pi/3? 3. That's it. Now, if it wasn't as pretty and easy as this, you could cross multiply and solve for B, but it's just that simple. I've got B is 3 because 2 pi divided by 3 or by B is my period, and my period this time is 2 pi over 3. That means that my b for my cosine is also going to be 3. Okay, everyone okay with that so far? All right, the only thing that's different is my period shift for cosine. So I want to look at my graph and see where would cosine start. Remember, cosine starts high and ends high, and then its middle point is the lowest point. So what's the highest point on my graph? What x value has the highest point on my graph? Good, pi over 3. So if I were to start my cosine graph here, that would make sense. So that means that my shift is going all the way over to pi over 3. So I'm going right pi over 3 for my cosine shift. Normally it starts at 0. We moved over to the right pi over 3. Okay. Again, we already did this, so it might be hard kind of thinking about it while you already have notes on this. We're going to go do 2b right now to kind of re-solidify that. Is that okay? Okay. Let's jump over to letter B. I'm going to start like I just did the last one. I'm going to set up my sine and cosine equations. I'm going to say y equals blank sine of bx minus c. I'm going to do the same thing for cosine. All right, now I'm going to ask you, what kind of graph does it look like we see right here? Does it look like a cosine or does it look like a sine? Looks like a cosine. Good. Okay, so I'm going to focus on my cosine graph first. Did I move left or right any for this to be cosine? No, I did not shift left or right. It stayed exactly where it was. So you can think about it being a plus or minus 0 in there. Technically, you could just not have anything. You could just get rid of that spot right here. Like if I were to erase it and just end my parentheses right here, that's okay. But if you're like, oh, I like knowing that I didn't move left or right any, then I can put a 0 there. Okay. Let's do our amplitude now. I think amplitude is pretty easy. How high does it go? Or what would my amplitude be? 6. Good. I know it looks like it might go past 6. Pretend like it's on the line. So my amplitude for both sine and cosine is 6. All right, now we're going to get into the period, okay? So if it starts at 0, then I can just go to where it ends. That's going to be what my period is. So if it starts at 0, and then it goes until this point right here, that's the horizontal length of my graph. That's the period. So the period for this, I actually don't have much work to do. It's just 15 pi over 9. Are you guys okay with that?
Yeah.
Okay, now what the hard part is now we have to figure out what b is. Because it's not going to be as easy as just looking at the equation like we did on the last one. This time, I have to think about doing 15 pi over 9 is equal to 2 pi over b. And we're going to have to solve for b. So 2 pi divided by something is going to give me 15 pi over 9. I just don't know what that is right now. So let's cross multiply and solve. So I get 15 pi b equals 18 pi. All right, and then I want to get b all by itself, so let's divide by 15 pi. B equals is that 6 over 5 pi? 6 pi over 5. If I take a 3 out, then I get 6, and I take a 3 out, I get 5. 6 pi over 5. I know that that's ugly, but that is my b. So I'm going to go put that in here. All right, we're almost done. The last thing we need to do is do my horizontal shift for my sine graph. Remember that sine starts in the middle of my picture, so sine would technically start like on the x-axis somewhere. This is the first time I see it on the x-axis. Now, the only thing I want to point out is normally when we do sine, we go like up and then we come back down and through, but that's not what my graph looks like, right? It looks like it goes down first and then comes back up. How do I represent that where it starts, then it goes down? How do I represent that it's not going up to begin with, it's going down to begin with? If it normally goes like this, what did I do to my graph? If it should match the green line. I flip it. How do you represent that we flip it? A what? Change what sign? Change what to a positive?
The sign after the X.
Nope. That does my left and right shift, so I don't want to change that.
The one out.
The 6 needs to be negative. Good, the out front needs to be negative. You remember last time we did notes, I wrote flip or vertical stretch, and I think we talked about flip on which one? Maybe this one right here, letter D, we talked about flipping our graph to represent that negative number. Okay, now that being said, I still haven't done my left or right movement. What's my horizontal shift here? My graph starts at pi over 3. Did I go to the left or the right? Right, so it's gonna say minus. If it makes you happy, you can write right in there, minus. Okay. I know this is all yucky, but like, we're gonna be required to do this, and what questions do we have yet? Anything? Okay, let's go back up, let's do H and I quickly, and then we'll go to the last one, number 3, and see how much of that we can cover. Okay, so on this one, we always do amplitude and period first, so let's do amplitude. What's my amplitude on this letter H? 2, very good. It should be really easy. We all should know amplitude is 2. My period is determined by B, so I have to do 2 pi divided by B. Okay, this might be kind of gross. 2 pi divided by 1/3. Well, that's the same thing as doing 2 pi times 3, which is 6 pi. Okay, that's not too terrible. All right, and then last, in order to figure out my shift, we got to distribute this 1/3 inside my parentheses. And distribute that on the inside. Sorry, I was thinking for a second. All right, so that's -2 sine 1/3 x minus pi over 21. So my shift, I'm shifting. I'm gonna say my new starting point, I believe that's what we talked about last time, SP is a starting point. Instead of starting at 0, 0, we're gonna go right pi over 21. And so we're gonna start at 0, comma, pi over 21. Okay. I believe the last one we did is very similar to this one, letter G, where I told us, let's get our normal angles, and then we're gonna move everything back pi over 21. So I'm gonna do that again here, okay? I'm sure we didn't spend a lot of time this weekend thinking about this, so I'll try and go slow, okay? First thing is I'm gonna mark my amplitude, and let's figure out my period angles. So my amplitude is going up to 2, +1, 2, -1, 2. And normally my angles would go from 0 to pi over 6. Or sorry, not pi over 6, 6 pi. Normally I go from 0 to 6 pi. Now, let's figure out what our other important angles are from here, okay? So we should have a total of 5 angles. In order to get 6 pi, we took 2 pi and multiplied it by 3. So let's go take our normal sine angles and multiply them by 3. So I'm going to take pi over 2 times 3. I'm going to take pi times 3. I'm going to take 3 pi over 2 times 3. Are you guys okay with that? Okay. Multiply everything by 3. So pi over 2 times 3 is going to be 3 pi over 2. Pi times 3 is 3 pi. And then 3 pi over 2 times 3 is 9 pi over 2. Okay, that's not what I want though, because I want to move everything to the right, pi over 21. So I'm going to move everything to the right, pi over 21. So I did those green angles to give myself kind of a guide. Now I'm going to take that green angle and I'm going to I'm going to add pi over 21 to go to the right. The confusing part about here is we're just doing some fraction work. So 0 plus pi over 21 isn't hard because that's just going to be pi over 21. But when I have to do all the other ones, like 3 pi over 2 plus pi over 21, I'm going to have to do some fraction work, aren't I? I'm going to have to get some like denominators. So I'm going to multiply the first one by 2, or the second one by 2 on top and bottom, the first one by 21 on top and bottom, and I'm going to get 63 pi over 42 plus 2 pi over 42 is going to give me 65 pi over 42. So when I move my 3 pi over 2 to the right, pi over 21, that takes us to 65 pi over 42. Ugly, but that's the right fraction. We're going to do that with 3 pi, with 9 pi over 2, and with 6 pi. You guys all okay on what I'm doing? Okay, let's keep going. So now we'll do 3 pi. Three pi plus pi over 21, we can think of that as 3 pi over 1. So multiply by 21 on the first fraction. So that gives me 63 pi over 21 plus pi over 21, which is going to be 64 pi over 21. Now, once you make these orange angles, if you want, you can erase the green angles and even like the arrows that I drew, if that makes it nicer and prettier for you. I'm going to leave them all on there just so you kind of know what I was doing and how I got there. But if you, once you move it, you want to erase all that extra scratch mark, you feel free to. It's totally fine. All right, now I'm going to do 9 pi over 2 plus pi over 21. So again, I'm going to have an ugly 42 on my bottom because I'm going to multiply 2 by the second fraction, 21 by the first one. $191 pi over 42. And then the last one I need to make 6 pi have like denominators. This is really ugly with these fractions, but at the end of the day, it's nothing crazy. I'm just adding fractions and getting like denominators. It's just annoying work. All right, and so now I want to make that over 1 and multiply by 21 on top and bottom. So I end with 127 pi over 21. I need all of those angles labeled so that we can know where all of our points are. Yes, Megan. I added it to all of them because we're going right pi over 21. I think I only added it once, but I just like rewrote this as a fraction and then I added it to it. Good question, good question. All right, now I'm gonna make my box so I can do my graph from here. So my farthest left point is pi over 21. My farthest right point is 127 pi over 21. My lowest point is -2 and my highest point is +2. I will tell you that, like, I know what we just did was a lot of work and kind of tedious. That's one of the smaller parts of this whole problem. So don't stress out too much about this. If you can get the graph right, even if you don't have your points labeled correctly, at least that works. And I believe that this box is really helpful. So you get as high as the graph needs to go and you go as far over as the graph needs to go. So I highly encourage drawing this little box to kind of keep everything in order. Okay, now I'm going to remind myself it's a sine graph. So my sine graph, again, we learned up here. The first, the middle, and the last point are all in the center of the graph. The second point's the highest and the fourth point's the lowest. However, I have a negative, so that means I'm gonna flip it. My first and my middle and my last points are still in the center of the graph. However, instead of starting to go to my second point by going up, we're gonna go down to get to my second point, and my fourth point will be the highest. So it's a flipped sine graph. It looks something like this. All right, that was a lot of work just to graph that. We've got one more with kind of weird fractions. Next one might have a couple weird ones, not as weird as what we're looking at. You guys ready to move on to letter I? Okay. Again, we still don't have any up or down. We haven't done any up or down movement. We'll do that in a second. All right, it looks like I already have our equation multiplied through. I multiplied everything by my parentheses by 2/3. So I have 2/3x and then plus pi over 6 times 2/3 is going to be pi over 9. So I'm glad I have all of that to help me identify my amplitude, my period, and my horizontal shifts. So what is my amplitude going to be here? We always start there. 2/3. 2/3, good. And since we're not moving up or down any, we can go mark our 2/3 on our graph. Wherever you want to put 2/3, go ahead and put 2/3, positive and negative. All right, then we do our period. Remember, period is 2 pi divided by b. So it's not 2/3, it's going to be 2 pi divided by 2/3. All right, so 2 pi divided by 2/3 is times 3/2. Oh, which the 2's cancel and I just get 3 pi. That's not too crazy. So in order to get my period, I did 3/2 times 2 pi. And so that means my last vantage point, I guess, is going to be pi or 3 pi. While we're here, let's go find our other reference angles. I'm taking all of my normal points and multiplying by 3/2. I'll even do it down at the bottom if that's helpful. So 3/2 times all of my points. So I'm going to do pi over 2 times 3/2, which is 3 pi over 4. I'm going to do 3/2 times pi, which will get me 3 pi over 2. And then we'll do 3/2 times 3 pi over 2, which is 9 pi over 4. Now, we do have a different starting point. We do have a different horizontal shift. So we can't just draw our box yet. Instead of starting on 0, am I moving left or right? Left, how many?
but I don't think.
Good, so we're going left pi over 9. So I'm gonna think about, normally we start at 1, 0, or 0, 1. Normally we go from 0, 1. Instead, I'm gonna be at left pi over 9, so I'm gonna be at negative pi over 9. And instead of being at 1, we're doing our amplitude at 2/3. Now, if this is not a really helpful thing to write, you don't have to write that. It's not a helpful color. You don't have to write this down if it's not helpful to you. I find it a little helpful, but if you're like, okay, well, I know I'm moving left pi over 9 and our amplitude is 2/3, you can just deal with that as is. So that means I need to move my point to the left, negative pi over 9. So we're gonna take all of our angles and we're gonna minus pi over 9 this time. So now we've got a lot of our little fraction work to do, but we can do this. So 0 minus pi over 9 is negative pi over 9. Now I'm gonna do 3 pi over 4 minus pi over 9. All right, like denominators, I need times 4 and times 9. 27 pi over 36 minus 4 pi over 36, which is 23 pi over 36. I know mine's a little messy because I'm like writing over my other numbers, but that's okay. Yes,
Why are we subtracting pi over 9?
good, because we're moving left pi over 9.
Oh, fine.
So we're taking all our points and just shifting left pi over 9. Good question. All right, so now I'm gonna do my next point, 3 pi over 2 minus pi over 9. So this time I'm gonna multiply by 9 and by 2 in order to get like denominators. So 27 pi over 18 minus 2 pi over 18 equals 25 pi over 18. Okay. Now we'll do 9 pi over 4 minus that from pi over 9. So my next point, I get 77 pi over 36. And then last we'll do 3 pi minus pi over 9. And think of that as 3 pi over 1, so multiply by 9 to get 27 pi over 9. Minus pi over 9 is gonna be 26 pi over 9. Okay. Now I'm using all those orange angles, those are my reference angles, that's where my 5 important points are gonna go. So I'm gonna draw my little box, my farthest left is negative pi over 9, my farthest right is 26 pi over 9, my lowest is negative 2/3, my highest is positive 2/3. Once I draw this box, I'm just gonna use my general cosine points. So my cosine points up here, the first and last are the highest, the middle one's the lowest, and then the second and the fourth point just go in the center of the graph. So I'm gonna come down here and I'm gonna graph my highest points. First and last are highest, the middle is the lowest, and then second and fourth just go through the center of the graph. Or something like that. Okay. Those were yucky fractions. I will not have as yucky fractions of those on any test or quiz, I promise, okay? But I want to do harder stuff now so that when you do easier stuff, it makes a little bit more sense, okay? We're doing hard stuff together. I know this is still tough. I do have 2 more examples I do want to get through. Is everybody hanging in there? Okay. Okay. All right, go ahead and flip your paper over. We're gonna do 3A and B. We will not do number 4. You will not be responsible for that. I'm not teaching that. Cool. Okay. Now, what I've got on 3A and B is I have all sorts of transformations. I've got ups and downs, lefts and rights, stretches, shrinks, all that fun stuff. So we're just gonna take this as slowly as we need to, but I want to do as many of these. If I can do both of them, that would be awesome. Okay. All right, we always start with amplitude. What's my amplitude?
2,
2. Good. What does that negative up front mean? Good. I do not want you to ever write that your amplitude is -2. Amplitude is a distance. Don't make it negative, but you can write a flip next to it to remind you that it has to change, that the negative does mean something. Okay. Now let's do our period. We're pretty good at that too. How do I find my period?
You multiply that inside by.
Okay, yeah, we'll multiply everything inside by 3, so I get 3x plus pi over 2. Okay. But then what part of that helps me with my period?
So pi over 2.
That's not your period.
Oh, it's 3.
The 3 helps me. Is 3 my period?
Now we get to divide that.
You have to do 2 pi divided by b. That's the biggest mistake we make, is we forget that you have to do 2 pi divided by b. 2 pi divided by 3. Oh, and that's actually as good as it gets. 2 pi over 3 is as good as it gets. All right, PS is like your horizontal shift. It's your left and right.
That's what I'm.
And then VS means your vertical shift, and that's your like up and downs. So do I go left or right? How many? And then we haven't done any up or down shifts yet, but we have them here. What does that +1 do to the end of my graph?
You go on.
Go up 1, good. And then I'm not gonna do frequency, so you can just cross that out. Okay. All right, let's go start labeling my graph. I still want to do amplitude first, but I need to take into account that we're moving up 1. So if my amplitude is at 2, so that means normally my lowest point would be -2 and my highest point would be +2. However, if I'm moving up 1 unit, what's my lowest point?
3.
Lowest point.
Hold on.
Nope. I was at -2 and I'm moving up 1. I was at +2 and -2, but now I'm gonna move up 1, so I'm gonna be at -1. And then my highest point is not gonna be at 2, I'm gonna move up 1, it's gonna be at 3. And so generally, I'm probably gonna erase the marks of -2 and +2, just so I only see 3 and 1, that's all I care about. Okay. Now, we can think about our period. And we can think about our period shifts, okay? So our period is generally 2 pi over 3. So let's label our graph like we normally would. We're gonna come over here. I'll put 2 pi over 3 right about here. And then we'll move everything to the left, pi over 2 in a second. Okay, I do want to find all my normal points though. To get my period of 2 pi over 3, we took our normal point of 2 pi and divided it by 3. So I'm going to take my normal points and divide them by 3, okay? You can think of it as pi over 2 divided by 3, or times 1/3, which makes my first point pi over 6. I can think of it as pi times 1/3, which is going to be pi over 3. And then I can think of it as 3 pi over 2 times 1/3, which is just going to be pi over 2. Okay, you guys okay with those marks? Okay, now we're gonna minus pi over 2 from all of these, okay? On all the last ones, I just did a little tiny bunny hop because we were just minusing like pi over 7 or pi over 21. However, if I do these points minus pi over 2, you already see that I have a point that's at pi over 2.
Yeah.
If I do pi over 2 minus pi over 2, where is that point going to move to? 0. So that means this point's moving all the way over there. So I can't just do a tiny little bunny hop. Let's figure out where all these points are and we'll put them on the graph, okay? I'm actually going to work backwards on this one. So the next one I'm going to do is 2 pi over 3, because that's going to be a good one for me. So 0 is going to be a point that we're at. Let's do 2 pi over 3 minus pi over 2. I still have funny fractions, but it's going to work out on this one because they're going to appear on my graph, I promise. I'm going to multiply by 2 on the first fraction, multiply by 3 on the second. That gives me 4 pi over 6 minus 3 pi over 6. Which is 1 pi over 6. Is that on my graph already?
Yeah.
Yeah. Pi over 6 is actually a point I am going to use. And that's going to be my last point. So all of the other points need to be on the left side of pi over 6. So when I minus pi over 2, my last point moved here, my second point moved there. So I've got 3 more points to keep moving to the left. Are you guys okay with that? Okay, so just like we did before, we're going to keep minusing these off. So I've got to do, we already did pi over, or 2 pi over 3, we minus that from pi over 2. We already did pi over 2 minus pi over 2. I still have to do 0, pi over 6, and pi over 3. So we're going to do those now. So pi over 3 minus pi over 2, multiplied by 2, multiplied by 3. That's 2 pi over 6 minus 3 pi over 6, which is 1 pi over 6. Oop, negative 1 pi over 6. So that means over here, I've got a negative pi over 6. Before I do any more math, does anyone think they know what the next point I should draw on here should be? So my first point was positive pi over 6. Then I did 0. Then I did negative pi over 6. What do you think my next point's going to be? Negative 2 pi over 6, which is good, which is negative pi over 3. You could do your math out, but it will give us that. Ooh, are you seeing that all the points I had on the right side are now going to be reflected over to the left side? What's the last point that I need? I don't even need to go that far. We're just going to go one more. We're just going to go negative pi over 2. You could put that out there, but I'm going to say that that will not be part of our graph. Because now I have 5 points. I've got positive pi over 6, 0, negative pi over 6, negative pi over 3, and negative pi over 2. And I'm going to argue if we kept going, those would be the points that you get. I just would like to do a little bit less math today. Okay, I'm going to go draw my barrier. So my left or my right hand side is already at pi over 6. My left hand side is going to be at negative pi over 2. The highest is going to be at positive 3, and the lowest is going to be at negative 1. Now I'm also going to draw a dashed line for the middle of my graph. On all the other points of my graph, the middle was at 0, but I moved up 1 unit. So what's the middle of my graph now? 1. So before I had points on the x-axis, I'm not going to have any distinct points on the x-axis. Those points are going to be centered around 1 now. All right, it is a sine graph and it is flipped. Do you remember how sine starts and ends and how its middle point is? That's cosine. Sine starts, middle, and ends in the center, right? And normally sine starts by going up, but it says that it's negative, it's flipped, so it's going to start by going down. And its 4th point is going to be the highest. something like this. How we doing? Okay. All right, let's see how much of the next one we can cover, okay? All right, let's see, what's my amplitude on this one? 1/2. Do I have to distribute anything or is it good? It's good, so I'm gonna do my period by 2 pi divided by 3, very good. Oh, and that's as simple as it gets, that's what it was last time. My period shift or my left or right switch is how much? Pi. Is that right or left?
Right.
Right, pi. And then my vertical shift up and down is
Down to.
down 2. And then no frequency, we're not gonna worry about that. Okay. So my amplitude is 1/2, so normally I would be at positive 1/2 and negative 1/2. But I have to shift my graph down 2 units. So you know what my highest and my lowest point are gonna be then? So the highest point is not gonna be 1/2, it's gonna be 1/2 minus 2.
Negative.
Good, negative 1 and 1/2. And then my lowest point isn't gonna be negative 1/2, it's gonna be negative 1/2 minus 2. Which would be negative 2.5. I'm actually gonna get rid of those. Oh, I do want this one. Get rid of those, because I want only negative 1.5 and negative 2.5. Because we went down 2 units. So my whole, normally I'd be around 1/2 and negative 1/2, but I've got to go all the way down 2 units. So now I'm surrounding negative 2, but I'm up 1/2 a unit and down 1/2 a unit. Good question. Okay. Now. Let's do our period stuff. We are moving everything right pi. So I'm not gonna put my 2 pi over 3 at the end. I'm gonna put him more in the middle because everything is gonna be right a whole pi from there, right? So I don't want him too far at the end, so I don't have to go too crazy far over there. So I'll put my 2 pi over 3 here, but I do want to figure out what all my normal angles are so that I can add pi to them, okay? So we're normally at 0. And again, to get my period, we did 2 pi divided by 3. So I'm thinking about all of my angles divided by 3. Wait, did we just do that? Didn't we just do all of our angles divided by 3? Okay, great. So I'm going to use the angles that I was using above. So I'm going to have pi over 6, pi over 3, and pi over 2. Okay, even easier. Now I have to add pi to all of those, okay? So I'm gonna do 0 plus 2, 0 plus pi is just pi. If I'm gonna keep my scale kind of similar, let me just move this over a little bit. If I'm gonna keep my scale kind of similar, I think pi should be about here. This in between stuff won't matter to me, but if I want to kind of keep it to scale, I'll put pi over here. All right, the next point is going to be pi over 6 plus pi, which is 7 pi over 6. Oh, maybe I should do this in orange. Let me keep my colors consistent. And then we're going to do pi over 3 plus pi, which is 4 pi over 3. Then we're going to do pi over 2 plus pi, which is 3 pi over 2. And then last, we're going to do 2 pi over 3 plus pi, which is 8 pi over 3. Now, is that right? No, it's 5 pi over 3. Sorry, I'm tripping. There we go. All right, I've got my 5 little points. I've got my barrier, so I know the farthest left I'm going is pi. The farthest right I'm going is 5 pi over 3. The lowest point I'm going is negative 2 pi, 2.5, and the highest I'm doing is positive 1.5. So I'm looking at solely this little box right here. And we want to graph normal cosine. What does normal cosine look like?
Starts falling. Down, and then it goes back up.
First and last point are high, middle point is low. And then technically the second and the fourth point are right in the middle. And right in the middle of this graph would be at -2. So if that's helpful to you, you can draw a little dashed line in the middle. But as long as I'm kind of seeing it in my box and it goes right through the middle, I'm okay. Draw our cosine graph. Looks something like this. Someone in my last class was asking about, like, is this all you see? No, it would keep going. I don't wanna worry about it would go something like that. So it would keep waving on and on if you want to do that, but I just want to really clear one period, okay? Okay, your 4.4 homework is due next time I see you. I know this is hard stuff, but I need you to struggle with this and try this on your own. Because if you just come to class tomorrow and copy what's on my key, you will fail this part of the test. And that's not a threat, that's just a fact. It's not, but you need to try it on your own so you see what you know and what you don't know. So I'd rather you come in with it completely wrong and you redo it than you come in with it blank and you be like, oh, I understand what Miss White's doing. You won't be able to do it on your own. That's my little spiel for the day.